The Chinese mini mills have a problem. The column is quite short with very little room between a vise and a Jacob's chuck. This makes it impossible to change between short drill bits and long drill bits. When you drill larger holes, you need to start with a small drill and then change to incrementally larger drills. This requires the bed to remain locked in the same place, directly under the chuck. This works well as long as you can move the head up far enough to swap the drill bits out. The problem is that you quickly run out of room as the drill bit gets larger and therefore longer. Large diameter drills usually are much longer than smaller ones. The problem gets much worse when you use a rotary table with the workpiece mounted in a chuck. Then there is very little space for changing drill bits. The same problem appears when changing between spindle tool holders such as collet chucks, face mills, boring heads, and not even to mention an Albrecht chuck, which is longer than a Jacob's chuck. If you do find yourself where you have to change a drill bit or a tool holder and there is no room for the operation, then you would need to move the bed with the workpiece out to create space to change the drill bit. The problem is that I regularly make a mistake when returning the bed with the workpiece to the same position. If you have a DRO, then the problem is not that serious, but I do not have a DRO, and DROs are expensive, so it's not an option for me. So, what to do? It would be great if I can raise the head of the milling machine just a little bit more to enable tool changes. Maybe another 10 centimeter or 4 inches. It does not have to be very rigid, as I will not be milling that far up on the column. I will make a cap that will fit on top of the column, and on that I will mount a raised stopping block. That way I can raise the milling head all the way to the top of the column dovetail slots. Currently, there is a part of the column that is not used for anything other than mounting the current travel stop. I will also need to extend the gear rack to enable the milling head to be lifted that high. The current gear rack is not long enough for that. Instead of buying a longer and expensive custom gear rack, I will buy a second OEM gear rack from the supplier where I bought the milling machine. That way I know that I have the correct gear rack. I got this gear rack for 220 Rand, which is about $12. I will cut the new gear rack into two parts and mount one half on top and the remainder below the current gear rack. There is already 4 mounting holes in the column, one above and another below the current gear rack. I think that those holes might have been intended for a longer gear rack. By keeping the current gear rack in its original position, I will be retaining that gear rack in a position where the hardest work is performed. The result is that I will have twice as long a gear rack with an accompanying longer travel, both upwards and downwards. Here are the parts that makes up the work envelope extender. Let us assemble the top cap. The top cap consists of 2 parts of off-cut steel that I had lying around. This part enables the upper gear rack to rest against the top cap. The stand-up mounting plate enables the current stop to be mounted so that it stands high above the column. And that is the top cap assembled. The top cap assembly can now be mounted onto the mill column and held in place with Allen bolts from the sides. The upper part of the gear rack can now be installed. I have milled the upper gear rack so that it can be mounted flush against the main gear rack, forming one contiguous gear rack. That way, the mill head can run smoothly across both parts of the gear rack. It is possible that the gear rack can slip upwards as the head is lowered. To prevent that, I have used a grub screw in a top gear rack that screws into a hole in the top cap. The hole is angled downwards. As the grub screw is screwed deeper into the angled hole, it will push the gear rack downwards and tight onto the main gear rack. The current Z-axis work envelope has been extended upwards by 10.5 cm or 4 inch, which should make a significant difference and make it possible to do tool changes. The Z-axis work envelope is measured between the top of the milling table and the bottom of the spindle. The total work envelope is now 375 mm, nearly 15 inches. The bottom gear rack allows a milling head to extend right down onto the milling table. When you use a gas strut in place of the standard spring lift, then it is possible to lower the milling head below the existing gear rack. The last thing that you want is that the milling head moves below the gear rack and falls onto your workpiece. That is what the bottom gear rack extension prevents. If you think this is a great idea, then please vote for it with the like button. I will be tracking the popularity of the ideas and will share the results in a future video. Let's test the solution and see how well it performs. It was almost impossible to change tools when using a rotary table. With the extended work envelope, it is much easier, and I do not have to move the milling table out of the way at all. It is just as easy to change spindle tool holders. Thank you for watching. I hope that you enjoyed this video and that you can use this idea in your DIY workshop. You are the reason that I am making these videos. Please tell your friends about this channel. I will really appreciate it.